Hello class. Today we're looking at our next section. It's on proportion sampling. And when we're talking about proportions, we're looking at really two things. Either do we have a success or do we have a failure? Did what we want to happen or did it not? And again, it could be cats and dogs and those wins and losses. It doesn't have to be good and bad things. It's just one's called success and one's called failure. We use the symbol P for successes, and successes would be calculated then as a success over the total. And then we use the letter Q to record our failures, our proportion of failures. And that would be the failures over the total number. Our formulas to calculate, the two things we're interested in our distributions is the mean. So the mean of the proportions, it's just like it was in the last section, it's just the mean. Easy to calculate. What you see is what you get. However, similar to the last section, the standard deviation of the proportions is calculated slightly differently. And we take P and we take the value Q and multiply them together, divide by this N, and then we take the square root of everybody this time, not just the N. We take the square root of the P, the Q, and the N. Make sure to follow your order of operations. The last thing for this section is we need to make sure we have a large enough sample size so that these formulas work. So we need a large enough sample size. How do we calculate that? Well, for the successes, the formula that we're going to need to use to make sure the sample size is large enough is N times P, and that's going to have to be greater than or equal to 10. The formula for the failures is very much the same. So you want to take a look at your formula sheet and see if these formulas were provided to you by the math department. But it's N times Q would have to be greater than or equal to 10. We have some room here. Let's do one example. So let's say we have a sample size of 50. Is that large enough? Well, it depends. It depends upon P. So let's say P is 30%, or we could just say 0.3. So now we need to check to see if it's large enough. So N times P, that would be 50 times 0.3. Notice that that is 15. That's greater than 10. It looks like it might work. And then N times Q, that's 50. Now the opposite of rain is no rain, so the opposite of 30% is 70%. We multiply that. Oh, very nice. 35. That's also greater than 10. So this time the sample size is large enough. All right. I'll look on the discussion board for any questions that you might have.